6b is a similar calculation to 6a with the math going the other direction. We're given the K, ask for the solubility, which is the molarity. So once again, I do have a Rice table, but if you're comfortable with and familiar with KSP, you may not need to write it. We write out our formula. The reason to think about that is to make sure that we understand that these subscripts are going to become coefficients. So I have a certain amount of copper. When I write my KSP, my iodate ion is squared, but then also, which is evidenced up here, the concentration of those, for every 1 copper, I get 2 iodates. So not only do I square it, I have to double it. So we need to remember that, and we need to remember that the 2 is inside those parentheses. So the 2 gets squared and the x gets squared, and then we multiply it by another x, so it comes out to 4x cubed. The KSP value is given, so then we divide that by 4, we do the cube root, we get x. The moles of solid per liter, the molar solubility that can dissolve, is 3.3 times 10 to the negative third. And then when I fill that back in up here, it's not asked for in the question, but we want to remember that that's the moles of copper ion that we get, but we actually have twice as many moles per liter of iodate ion. So depending what you're asked, it's important to really pay attention to that and to remember that those coefficients play in a few times. I have twice as much of this ion as that one.